Hello folks, we are coming to the part 4 video of the exercise 3.3 and these are the questions which comes up. The ninth question proved that cos 3 pi by 2 plus x plus cos 2 pi plus x equal into cos 3 pi by 2 minus x plus cot, sorry this is cot, and cot 2 pi plus x, that will come to 1. Now what we do is, like before questions, because these things are not so very familiar to us, we will find out all these values, then we will substitute in the LHS and we'll get the answer. So let's start right away. Consider cos 3 pi by 2 plus x. Where does this lie? Cos 3 pi by 2 plus x lies in the fourth quadrant, and in the fourth quadrant it is a quadrant for cos and sec. As a result, the answer will be whatever that you get will be a positive answer. But word of caution, because there is 3 pi by 2, whenever 3 pi by 2 and pi by 2 is there, there is a sign change, there is a ratio change. So cos will become sine. So your answer is going to be sine x. That's how you get the answer. Let's take the next one, cos 2 pi plus x. Cos 2 pi plus x means it is, again, if you are looking at the ratio cos 2 pi plus x, it is in the first quadrant. First quadrant is all, it's open to all, it's a home for everybody. So every sign is going to be positive and every trigonometric ratio is going to be positive, and 2 pi is trouble free. So in order to get the conversion is very easy. You get it as cos x. That's quite easy. Then let's move to cot of 3 pi by 2 minus x. Now 3 pi by 2 quadrant wise is in the third quadrant, and third quadrant is a quadrant for tan and cot. So therefore that makes it comfortable, sign will be positive. But because it is 3 pi by 2, there will be a ratio change. Cot can become tan. So this is going to be positive tan x. Same way, cot 2 pi plus x, as we saw earlier, 2 pi plus x means it's in the first quadrant, and first quadrant every trigonometric ratio is positive. So cot 2 pi plus x will remain as cot x. So this is our conversion. Now let's consider the LHS. So in the LHS, cos 3 pi by 2 plus x, we got it as sin x. Then cos 2 pi plus x, we got it as cos x. And in the bracket, we got tan x plus cot x. Let's going to solve this, maybe that will help us. So writing tan x is like writing cos x, sin x by cos x, and writing cot x is like writing cos x by sin x. So we come across fractions which have the denominators are not equal, so we will make them equal by multiplying sin in the first case and multiplying cos in the second case. So we are getting sin x cos x, and here it's now become sin squared x, here it has become cos squared x. We have equalized the denominator and denominator has become sin x cos x. So what happens in that process, this sin x cos x, cos x, they can cancel each other, and this as an identity we know that sin squared x plus cos squared x is always 1. So therefore this comes up to 1, and that is exactly what the RHS is asking, and that's how we are proving this result, hence proved. That's about this. So that's our 9th question. Let's quickly come to the 10th one. Sin n plus 1x into sin n plus 2x plus cos n plus 1x into cos n plus 2x should show that it is equal to cos x. And I don't know whether we are able to observe something here like what we have observed in one of the previous problems. We are observing that, suppose if we plan to call this as A and we plan to call this as B, then here is A and here is B. So what happens is, we are getting sin A sin B plus cos A cos B, and we know by a formula that cos A cos B plus sin A sin B is nothing but cos A minus B. We have learnt it. So exactly this we are going to use over here, and we are going to get consider the LHS, and there we are using this formula. Because of this formula, we are no longer going to write it like that. We are going to make it as cos A minus B. That means cos A is this and B is this expression. Let's solve this. Cos nx plus x minus nx minus 2x. So what will happen? Nx and x will cancel. X minus 2x, it will become minus x. And we have learnt long ago that cos minus x is cos x. So like that, this becomes our RHS. That's how we prove our result. Hence proved. That's about this. That's our 10th question. Now let's go to the 11th. What does the 11th question say? It is cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x. You have got, I have not written what you have got to show it to be equal to. Let's quickly write what is it. Minus root 2 sin x. Okay, so probably you could have your formula cos a minus b coming into picture. I don't know whether we are aware of it. Cos a minus b, it works as minus 2 sine a plus b by 2 into sine a minus b by 2. We are going to use this and let's see how it is. So we consider the LHS and there we are using this formula. So it's going to be minus 2 sine a plus b, that is 3 pi by 4 plus x plus 3 pi by 4 minus x whole divided by 2. First term, second term sine 3 pi by 4 plus x minus 3 pi by 4. Because it's minus, there is a sign change and you get this minus 3 pi by 4 minus into minus plus. You have the terms like this. Let's see now how this is simplifying. This is minus 2 plus x minus x cancels here, plus 3 by 4 minus 3 by 4 cancels. So what are we left with? We are left with sine. Now just check this. 3 pi by 4 plus 3 pi by 4. See, denominators are same. So 3 pi plus 3 pi, they will get added up and they will become 3 pi by 4 plus 3 pi by 4 will add up and it will get 6 pi by 4. But you also have this denominator 2. So like that it will become 6 pi by 8. But that on simplification will become 6 pi by 8 on simplification will become 3 pi by 4. So you're going to get this as sine 3 pi by 4 into sine